All right, guys, so let's review the jet stream, and then we're going to talk about the prevailing westerlies. So, first of all, you guys learned about the jet stream already, and the jet stream is the air current that's high in the atmosphere, and it runs like a tube of air that separates the warm air mass from the cold air mass. And of course, the jet stream flows from west to east. So the jet stream impacts our weather because areas north of the jet stream experience colder temperatures and areas south of the jet stream experience warmer temperatures. So that means that when the jet stream dips down below us, we experience cold temperatures, but when it moves above us, we experience warmer temperatures. So again, it's that boundary between the cold air mass and the warm air mass, but it does tend to fluctuate and it changes its dip and its curve so that sometimes it's above us, and when it is, it leaves us in that warm air mass, and then sometimes it dips down below us and it puts us in that cold air mass. So it really depends on where the jet stream is as to whether or not we are warmer than usual if we're down below it, or if it dips below us and it puts us in that cold air, then we're going to be colder than usual. All right, so, and again, since it flows from west to east, it also helps to move our weather systems, but there's also another weather pattern that helps to move our weather systems from west to east, like we've talked about, because weather starts with WE. That reminds us that it moves from west to east. But look at this video here, and we're going to focus specifically up on the northern hemisphere. So the northern hemisphere is above South America, so North America. So we're going to look, we're located about right here, and if you look at these lines, you can see that for the majority, they're moving from west to east, and then you've got lines that are moving below it, right near the equator, that are moving from east to west, and then you've got something else. You keep going further down, again, you've got the air that's moving from west to east, and then if you look even further, the wind kind of changes direction because we're looking at wind height here on this map. It changes direction as you get closer to the pole. So we're going to talk about that today and hopefully help to make some sense of this. So again, the winds travel from west to east in the northern hemisphere, and this causes us to receive our weather from the west. All right. So what we just saw on that map is right here in this little picture. We've got our global winds. Remember, the wind was moving from the west to the east. So we have our prevailing westerlies that move from the west to the east. And then you've got your westerlies in the southern hemisphere. But we really want to focus on the northern hemisphere. But also, one of the things I want you to notice is those trade winds that are right above the equator. And they move from east to west, and those are going to be important to look at when we start talking about hurricanes. So we've got our trade winds that blow from east to west, but the ones that really impact our weather are those prevailing westerlies. They move from west to east because, remember, winds are named by the direction from which they blow. Since they're blowing from the west, they're the westerlies. And our weather here in the United States is moved by the prevailing westerlies. So, using information that we've learned today, which weather pattern most influences the weather in North Carolina? Is it A, polar easterlies, B, tropical easterlies, C, tropical westerlies, or D, the prevailing westerlies? I want you to answer that now. All right, and if you said the prevailing westerlies, then you are right. Ba, 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 ba. All right, moving on. Now we're going to talk about the Gulf Stream and La Niña and El Nino. All right, so we talked about the Gulf Stream already, and the Gulf Stream is that warm surface water in the Atlantic Ocean that moves from the south of Florida up the east coast of the United States, and then back across the Atlantic Ocean all the way to Europe. All right, so how might the Gulf Stream impact our weather? We're going to talk about that here, or review it. The Gulf Stream, remember, since it warms that surface temperature of the water in the Atlantic Ocean, it warms the air and land along the East Coast during the cooler months. So as that warmer water evaporates into the air, that water vapor transfers its heat to the air around it. So again, our air on the coast is much warmer than the air further inland, which is why we tend not to see snow very often, because of that Gulf Stream warming up the water around us and then that warm water evaporating into the air. So here again is another picture of the Gulf Stream and how that warm water comes from the Gulf up around Florida and across the Atlantic Ocean. So, what impact does the Gulf Stream have on North Carolina's coastal climate? A, the cold water from the Gulf Stream coast cools the land. B, the warm water from the Gulf Stream coast warms the land. C, the cold water from the Gulf Stream current decreases inland wind speeds. Or D, the warm water from the Gulf Stream current increases inland wind speeds. Answer now. And if you said the warm water from the Gulf Stream current warms the land, you were correct. Alright. Well, I messed up making the slide. So we know that El Nino happens in December, but let's watch this video to figure out why.
People throw around the terms La Niña and El Nino quite a bit. That's because they're important climate patterns that impact things such as drought, hurricanes, torrential rainstorms, even the fish you eat for dinner. But what is El Nino and La Niña? We'll try to explain. First, El Nino roughly translates to little boy or a child, and it was named by South American fishermen who identified a change in the water temperatures and the types of fish they caught periodically with this temperature change. It happened most strongly around December and Christmas period, so they associate it with baby Jesus or the Christ child. So what happens during an El Nino year? Well, traditionally, we have the trade winds, and they blow east to west across the Pacific. That pushes all that surface warm water closer to Indonesia and Asia. That creates thunderstorms and showers over there, and we have the traditional airflow pattern. When the trade winds slack off, all of that warm water pulls back towards the equatorial Pacific and piles up along South America. That shifts the rainstorm patterns again. We have thunderstorms, and it affects the upper air patterns. During hurricane season, that means we have more wind shear in the Atlantic and less in the Pacific. So wind shear is a hurricane killer. That's why climatologists know that during a strong El Nino year, we'll typically have fewer hurricanes in the Atlantic. El Nino is typically stronger during the winter months. The warmer Pacific waters pump energy up into the subtropical jet stream, and that changes its pattern. What it means for Florida is more storms, cloudiness, and more rainfall. That played out perfectly in 2015, 2016. First, we had a super strong El Nino. We called it the Godzilla El Nino. 2015 marked the 10th year that Florida escaped a hurricane landfall. And during the winter, we had such torrential rainfall in January that it filled up Lake Okeechobee. The water managers had to send that extra water out the Caloosahatchee and St. Lucie estuaries. And what that did was help create a harmful algae bloom.
All right, guys. So what is El Nino? So El Nino is when the Pacific Ocean gets warmer than usual. And it causes, because the Pacific Ocean is warmer than usual, and of course we live in the world, and it's a globe shape, and everything is connected, because in a circle everything is connected, it's infinite. When you've got warmer water in the Pacific coast, that causes the cooler water to be pushed to the Atlantic Ocean, and it causes the Atlantic Ocean to be cooler than usual. But the thing about El Nino to remember is that most of our weather, the weather systems in the United States, I guess I'm backwards here on this video, they come from west to east. So El Nino usually happens in December, and it causes us to have more precipitation from the west because the Atlantic Ocean is cooler due to El Nino. Our chance of snow increases, but it causes changes in wind patterns that have major effects on weather all across the globe. And that was the decreased wind shears that they talked about and that type of thing. All right, so what we learned is that El Nino is the warming of the Pacific Ocean, causes the Atlantic Ocean to be cooler than usual. So what happens is we've got warm water in the Pacific Ocean here, and cooler water in the Atlantic Ocean, which is, the ocean that touches us. So I've got this cool little image here to help you to remember that El Nino, it's Spanish for the Niño, or the hot, stinky boy from the west. It causes that warm water to rise and cause lots of precipitation and weather systems to move from the west to the east. So increased precipitation in December. And since that Atlantic Ocean is cooler than usual, we have a greater chance of snow here on the coast. But even if it's not snow, we will have more precipitation in an El Nino year because remember, our weather systems move from the west to the east thanks to the prevailing westerlies and the jet stream. So El Nino, it happens in the winter months. You think of baby Jesus because that's where it got its name from. The baby boy happens in December, but we need to shift our thinking from that and think of a hot, stinky boy sitting on the west coast, perspirating, allowing all that moisture to get up in the air and work its way across the United States when we have an El Nino year. So, which causes North Carolina to experience an increase in winter precipitation? Would it be El Nino, La Niña, trade winds, or prevailing westerlies? Answer now. And if you said El Nino, you're correct. Woo woo. All right, now we're going to talk about La Niña.
That summer. Now that warm water on the equatorial Pacific can't stay there forever. Like a pendulum, it'll swing back and push back towards Indonesia, and we'll end up with a neutral period or La Niña. And La Niña is an abnormal cooling of the waters in the equatorial Pacific. What that means for Florida typically is a drier, warmer winter, and it can be more accommodating to hurricanes. We saw that in 2016 when we got hit by Hermine and had a close call with Matthew. This is why La Niña and El Nino are so closely monitored by forecasters. If you want to learn more about the weather, check out my weather blog at Palm Beach Post.
Alrighty, friends. So La Niña is when the Pacific Ocean is cooler than usual, and it causes the Atlantic Ocean to be warmer than usual. And now it's time to talk about hurricanes because they really impact us here on the east coast of North Carolina. So when you've got those warm ocean waters in the Pacific Ocean, in the Atlantic Ocean, and and a storm system comes from off the coast of Africa, and those trade winds start to push it, and it's fueled by that warm ocean water. What happens is the trade winds push it east, and it continues to build and build and build in strength because of that warm ocean water that it's in. And then when it gets up to the prevailing westerlies, it begins to curve up our coast of Florida and North Carolina. And so then you see that normal curve of the, you guys are backwards for me, so it's hard to, but anyways, you see that normal curve that the hurricanes usually make, and that is due to all of these things working together. So again, what is La Niña? It is a widespread cooling of the surface waters of the eastern tropical Pacific Ocean, which causes the warm water to be pushed over to the Atlantic Ocean, and we have warmer conditions off of our coast. And La Niña is opposite of El Nino. La Niña means the girl, El Nino means the boy. Those are opposite, so of course their weather is opposite. El Niña is the cold Pacific Ocean and a warm Atlantic Ocean. And here in North Carolina, we have more active hurricane season because of the warmer temperatures in the Atlantic Ocean. All right, so now we're going to watch a video to help us, again, to review El Nino and La Niña and how those, what causes the water to warm up in the Pacific Ocean or be cooler in the Atlantic Ocean or vice versa.
Warmer or colder than average ocean temperatures in one part of the world can influence weather around the globe. Boggles the mind, right? Here's how it works. During normal conditions, trade winds, which blow from east to west, push warm surface waters towards Asia, piling it up in the western Pacific. In some years, though, the trade winds weaken. The warm surface water moves eastward and reduces upwelling of cold water off the coast of South America. Climatologists call this El Niño. Its climate impacts show up mostly in the wintertime over North America. The warmer ocean fuels an intensification and southward shift of the jet stream. This brings flooding to the southern United States and warmer, drier conditions over parts of the Pacific Northwest, northern U.S., and Canada. But eventually, those trade winds pick up again and sometimes become even stronger than normal. When that happens, they blow the warm water back into the western Pacific and restart the upwelling of cool water towards the surface in the eastern Pacific. These strong trade winds are a signature of what is called La Niña, unusually cold conditions in the tropical Pacific that displace the jet stream northward. La Niña can lead to drought in the southern U.S. and cooler temperatures, heavy rains, and flooding in the Pacific Northwest. El Niño and La Niña together are part of a cycle that influences extreme weather and can impact food production, water supply, and even human health, not just in the U.S., but in many parts of the globe.
And that, my friends, is El Niña and La Niño in a nutshell. So again, remember La Niña means like the girl. So the Pacific Ocean is like Elsa. It's colder than usual. And which in turn makes the Atlantic Ocean warmer than usual. And of course, the warmer Atlantic Ocean means warmer water to fuel hurricanes. Our hurricanes usually are produced off the coast of Africa here. The trade winds push them towards us. And then the prevailing westerlies catch on to them, and then it pushes them along our coast. But again, remember, we've got that warm water that fuels the hurricane, so they've got plenty of time to build and to grow, especially in a La Niña year. All right, so we're going to review a little bit about what we've learned, and then we're going to watch a short little video about hurricanes. So again, jet stream, we've got the air current. It's high in the atmosphere. It separates the cold air mass from the warm air mass. It's like a tube of air that runs between those two, and it flows from west to east. The prevailing westerlies are a global wind pattern that blows from west to east across the United States and other countries at latitudes of 30 to 60 degrees, which is pretty much North America, or, United States. Gulf Stream, a warm ocean current in the Atlantic Ocean, and that flows from the south of Florida up the east coast and then across the Atlantic towards Europe. It causes our air and land to be warmer than usual. El Nino is a climate pattern, and it is unusual warming in the Pacific Ocean, which causes the Atlantic Ocean to be cooler than usual. And it impacts the weather and climate patterns from around the world because, remember, it decreases that wind shear, or it increases wind shear, which is really bad for hurricanes. They can't continue to build with wind shear. And it brings more rainstorms and higher temperatures for us. And again, lastly, we have La Niña, which is a widespread cooling of surface waters of the eastern tropical Pacific Ocean, and the opposite of El Niño. And it results in more hurricanes for us here during hurricane season. But other than that, drier weather than usual because the Atlantic Ocean is cooler, so it's not evaporating as much, which leads to less storm systems moving from west to east across the United States. So that's it for me. I'm going to send you guys to watch a video on hurricanes from Nearpod, and then you guys have a little activity to do after that. I hope you have an awesome day. I miss you. I love you. Bye.